Question 8. Figure 1 is a graph showing the trajectory of a rugby ball. The height of the ball above the ground h meters has been plotted against the horizontal distance x meters measured from the point where the ball was kicked. Ball travels in a vertical plane. Ball reaches a maximum height of 12 meters, so we can say up here is 12, and hits the ground 40 meters over here from where it started, 0 and 40. So if I were looking at finding a quadratic equation linking h with x that models this, what I would do is I would say, well, that point here is going to be halfway along, so that's going to be at 20. Now, if we were just looking at these points where it crosses, we could say that y is equal to x lots of x minus 40, because we could show there that our solutions are at 0 and at 40. However, we need to think that there might be a multiple of this. Okay, we don't know if there's more than 1x squared, so we've got to investigate. Now, by knowing that this point here is at 12, we can say that this curve is going to pass through the point 20 and 12. So therefore 12 is equal to a lots of 20 minus 40. So therefore we can say that 12 is equal to 400a minus 400. And so therefore a is equal to minus 3 over 100. This will therefore mean that the equation can be modelled as y is equal to minus 3 over 100 x minus 40 as a quadratic. The ball passes over a horizontal bar of a set of rugby posts that is perpendicular to the path of the ball. The bar is 3 meters above the ground. Use your equation to work out the greatest horizontal distance of the bar from the origin. So for part B, we've got our equation, and so we know that the height has got to be 3 meters, so 3 is equal to minus 3x over 100, x minus 40. So we take the 100 over, and we're going to get 300 is equal to minus 3x squared add 120x. So 3x squared minus 120x add 300 is equal to 0. Now if we divide by 3, x squared minus 40x add 100 is equal to 0. And so using the quadratic formula to solve, we're going to get that x is equal to 37.3 meters, or x is equal to 2.68 meters. So we're going to be basically saying that we've got one value of going past 3 meters about here, and one value of going past 3 meters about here. And seeing as we want the greatest distance, we're going to be looking at the furthest one away, and so we can say therefore x is equal to 37.3 meters. Part C. Give one limitation of the model, so air resistance is not taken into account, but any reasonable answer would be fine. But the easiest one to talk about is air resistance is not taken into account.